Stop worrying about homework and start learning with confidence. This is Ask Learn. Complete help for every subject. Like, share, subscribe for daily learning videos.
We're going to be solving problem 109 of Tro's chemistry, structure, and properties. And this is problem number 109 of chapter 1, Tro's chemistry and properties. And we're told that the United States Environmental Protection Agency sets a limit on the healthful levels of air pollutants. And we're told that based on this information, the maximum level that they deem okay for safe lead air pollution is 1.5 milligrams per meter cube. And assuming that our lungs have a capacity or total capacity of 5.50 liters, which determine how many lead atoms would be in our lungs. Right. So in this question, we've been given two useful pieces of information, which is 1.5 milligram per cubic meter and the total lung volume, which is 5.50 liters. In order to determine the number of atoms that, or the number of atoms of lead that would be present in our lungs, we actually need to know what the mass is, right? And once we get that mass, we can find the mole. And based on the mole, we can determine the number of atoms just by multiplying by Avogadro's number. Right, so given this expression here, right, determine the mass, right, we can determine the mass by multiplying density by volume. 1.5 millimeters is essentially a density value, right? But in order to multiply these two quantities, we have to realize that these two have different units, right? Here we have milligram per cubic meter, and here we have liters. So we have some unit conversion here. We first have to convert 1.5 milligrams per meter cube into preferably gram per cube. So doing that, we can have 1.5 milligram per meter cube, and essentially 1 meter cube is equal to 1,000 liters. So we can have 1 meter cube here over 1,000 liters. And we should also note that 1,000 milligrams is a gram, right? So if we have 1 gram here, we can have 1,000. We can have 1,000 milligrams. So here, this can cancel this. This can cancel this as well, right? So essentially, what we're going to be left with is gram per liter. So this is essentially 1.5 times 10 to the power minus 6 grams per liter. And to determine the mass, so the mass of lead, that's going to be 1.5 times 10 to the power minus 6 grams per liter multiplied by 5.50 liters. And that is going to give us 8.5 times 10 to the power minus 6. This unit is a mass. Right, now all we have to determine the number of atoms, right? So the number of lead atoms essentially we have to first find what the mole, right? So the mole is given by the mass over the molar mass. The molar mass of lead is 207.2. So we just have to do 8.25 10% to the power minus 6 grams over 207.2 grams per mole. And then we can multiply this by Avogadro's number, 6.023 times 10 to the power 23 atoms per mole. All right, so here what we're going to see is that we're going to have cancellation of grams, cancellation of mole, because this mole is going to go up. It's going to cancel that, and we're left with atoms. So upon solving this, our final answer is going to be 2.40 times 10 to the power 16 atoms of lead present, well, that's your lungs.